Today we're taking a look at division, but we're kind of breaking it down so you can see the why. This is pretty unique because there's things that I didn't even understand because this is not how my generation was taught division. And so we're going to be working them side by side the way we did in class today as kind of a refresher for you. So the first thing we're looking at here is making actual place value chart based on what we're working with. So in this case, you can see here's the standard algorithm version of it. So we take this one where it's the horizontal version, and we know that the first thing is what we're dividing. It goes here underneath what we call the house. What are you dividing by? So it's 5 and 241 thousandths. 5 and 241 thousandths divided by 3. Now we're going to take these, we're going to kind of group them up. 1, 2, 3, 4, 5 ones. We have 2 in the tenths place. We have 4 in the hundredths place. So we're making what are called discs. And I'm going to show you how we kind of divide those up at the end. And we also have a thousandth. So what we're looking at here is we're going to divide it into 3 equal groups. Here's 1 group, 2 groups, 3 groups. And so if we have ones and we're breaking it into 3 groups, we circle them and go, oh, we have 3 of them. Everybody gets 1. But in this case, we have 2, and we can't break 2 into 3 parts because there's only 2 of them. So these ones we're going to move on over like this. And so looking back at this a little bit, there's 1 in each group. If we look at the standard algorithm, 3 goes into 5. We can only fit 1 in. 1 times 3 is 3. Then we subtract, we get 2 left over. Here's the 2 that we have left over. They're right here. Here's 1 and here's 2. They're not circled yet. So we're going to move them over. So what we're actually doing is we're taking 2 ones and we're going to turn it into tenths. So then when you take this one and you drop it down, what you're actually looking at is 22 tenths. So let's make this into 22 tenths. 1, 2, 3, 4, 5. And I like to go in groups of 5 because it makes it easier when you're trying to figure out how many you have there to work with. So for example, if you had a 5 and 2 left over, you could think about that and go, oh yeah, I can see there's 2 extra, therefore I have got a 7. So in this case, we have, here's 1 set of 10, here's another set of 10, here's 2. So that's 22. It matches this. It's 22 tenths. Now we're going to group it into sets of 3. Here's a set of 3, everybody gets 1. You're going to get sick of me saying that because it's going to be over and over. Here's a set of 3, everybody gets 1. Here's a set of 3, everybody gets 1. 1, 2, 3. Here's a set of 3, everybody gets 1. Here's a set of 3, everybody gets 1. And we're at that 5 mark again. So we're going to make a second row. Here's a group of 3. Everybody gets 1. Group of 3. Everybody gets 1. And you can see that we have 1 left over. So that's going to go over here. Let's take a look at what we got here. 3 times what gets us close to? Let's see what we got. 5, 6, 7. So there's 7 here in each group. So therefore, this is probably going to be 7. 7 times 3 is 21. We subtract. We have a 1 left over. Oh, we have a 1 left over also. So now we're looking at 14 hundredths. The 4 is in the hundredths place. This 4 is in the hundredths place. So let's make it into 14 by taking that 1 tenth and turning it into 10 hundredths. Now we're going to say groups of 3. Here's a group of 3, everybody gets 1. Here's a group of 3, everybody gets 1. Here's a group of 3, everybody gets 1. Here's this one and 2 more. 3, everybody gets 1. So now when we take a look at this, there's 4 in each. 4 times 3 is 12. There's 2 left over. There's 2 left over. So we're going to move these over here so that our 2 hundredths becomes 20 thousandths. Here we go, still drawing, still drawing. Now we're at 10, that's one of our hundredths. Now we're doing our other hundredths. So it takes 10 hundredths to make a single, or sorry, 10 hundredths to make a tenth, 10 thousandths to make a hundredth, and so on. Now let's break it up again. Here is 1, and 2 more is 3. Everybody gets 1. Here's 3. Everybody gets 1. Here's 3. Everybody gets 1. Here's 2 plus an extra. Everybody gets 1. Here's 3. Everybody gets 1. And note we're at the 5 mark, so we're going to have to continue on down. Here's 3. Everybody gets 1. Goes separate. Here's 2, and here's 1 that's left over, so that's 3. Everybody gets 1. Now we go 5, 6, 7. And here we have that 4. We forgot to label it. So this is going to be a 7, according to this. 7 times 3, we had dropped down our 1, 21. 7 times 3 also is 21. You subtract, you get nothing left. We have nothing left. We used up all of these. So it matches. So it kind of helps you out with the understanding of why. We bring this decimal down. This decimal we bring up in our standard algorithm version. So it's 1 and 747 thousandths. And then we finished. The next thing that we're going to be taking a look at, we're halfway through here, just about 7 minutes in, we're going to be taking a look at using standard algorithm. And I'm going to do C, hardest one. So we're dividing by 6, so it goes outside the house. And then we've got 16 and 404 thousandths. I know 6 times 2 will get me 12. And I know that if I add 4 to 12, it gets me 16. Now I'm going to bring down another 4. I know that 6 times 7, I'm going to put the 7 above the 4 because I'm looking at 44, is 6 times 7, 42. I subtract, there's 2 left over. Bring down a 0. I know that 3 times 6 gets me 18, pretty close. 2 left over. Drop down our last 4. I know 6 times 4 is going to get me that, because 6 times 2 is 12. So if I double the 2, I double the 12 also. So the answer on that one, because 4 times 6 is 24, find the difference. There isn't any, and there's nothing over here. So we're done. 2 and 734 thousandths. I'm going to take a look at the most complicated word problem that we've got on this page. The total weight of 6 pieces of butter and a bag of sugar is 3 8/10 of a pound. If the weight of the bag of the sugar is 1 4/8 of a pound, 1 4/10 of a pound, what is the weight of each piece of butter? So in this case, this has got the butter. This does not have the butter. This is just the sugar. So let's take our butter and sugar combo and subtract, take out the sugar, and see how much left is butter. 8 take away 4 is 4. We had to line up our decimals so that we're subtracting tenths from tenths. Now we're going to subtract ones from ones, and we get 2.4. So it's 2.4 pounds of butter. But it's not asking just the butter in general, it's asking each piece. So we had 6 pieces of butter. We have to figure out now, 6 goes into 24 tenths. So if we're going into 24 tenths, we know it's not going to go a whole. 6 doesn't go into the whole 2, so we know that 6 times 4 got us 24 before, so nothing left over. We know in this case it would be 4 tenths, because we're going 6 into 24 tenths, so our answer will be tenths also. Alright, so here's your homework for tonight. I'm going to ask you to go ahead and try both problems. Let's make it so you can see it. Here we are. We have 5 and 372 thousandths divided by 2. So start by putting it in here. And if you're dividing by 2, make a line here. Draw it yourself. It's okay. It can be messy. And then you need to have 2 rows, make your dotted line here, so that when everybody gets one, here's your 2 everybody's. And then the last one, this one's just saying standard algorithm. Standard algorithm is just this. That's that style. So you don't have to do a place value chart. You absolutely can if you want to, if you find it very helpful. So anyway, we need an answer in this blank here. We need you to have a chart like that, and it can be messy, that's okay, with your discs. And then you're taking your discs and you're dividing them up between 2 equal parts. All right, hit pause, copy away. See you tomorrow.